How's it going, guys? Today, in this video, we're going over module 1.3, day 2. To use the warm-up, just pause the video really quickly. Try to do it yourself if you haven't. And in a second, I'll post the answers to it. All right. It is what you should have gotten. If you didn't really get this, you didn't get it right, it's a little confusing, go back to the previous video. Watch that if you have to. Go over your old notes, do what you need to do. But we're not going to spend too much time on this because this was covered in the last video, in the last day of notes. So we're going to keep going. Now we're going to talk about transforming the graph of the parent quadratic function. So in the previous video, in the previous day of notes, what we did is we kind of looked at each parameter by itself, what each parameter would do to the equation or do to a function. You know, if it stretches it vertically, compresses it vertically, stretches it horizontally, compresses it horizontally, or moves it up, down, left, or right. And now we're going to see what happens when we have multiple parameters, or we have multiple things changing the equation all at once. And how we're going to be transforming that graph to a new function. All right. So here we're talking about the parent quadratic function, f of x equals x squared. And that's going to be that U-shaped graph we see on the right. And we also call this a parabola. And when it comes to parabolas, what we need to do, or what we need, is 3 reference points. All right, we have a reference point at 0, 0, negative 1, 1, and 1, 1. And that'll be the 3 points we see here on the right of the graph. And we have to have 3 reference points because we need to know what's happening on both sides of the graph and also at the vertex. All right, the vertex we always need to know because that's like the center of the graph. But we also need to know how the left and right side of the graphs are going to look. So that's why we have to have 3 reference points. 1 for the vertex, 1 for the left side of the graph, and 1 for the right side. All right, so now on A, we have this equation right here, g of x equals negative 3, f of x minus 2 minus 4. So what we always need to do before we start actually trying to figure out the transformation rule or try to actually transform it is we're going to break it down to A, B, H, and K. We're going to break down our parameters. So our A, that's the very first one. Remember, it's A, f of 1 over b, x minus h plus k. That's the g of x. Let's put that in the front as well. G of x equals all of that. So our A, when we compare both of these, is negative 3. And that's going to be a vertical stretch of the graph f of x by a factor of 3, and a reflection across the x-axis, or a vertical reflection because our A is negative. And it's a vertical stretch because we have a 3 as our A value. Our B, we see we don't actually have a B here, and that just means our B is 1. If you don't see something multiplying to x or something multiplying the equation outside of it, that parameter is going to be 1. So in this case, our B is 1, since if we plug in 1 into our B in this equation right here in the front, at the top, we get 1 over 1, or just 1, or in other words, it just goes away. So our B here is 1. Our h, that's going to be a positive 2. Remember, it's x minus h. So this x minus h here tells us that our h is 2. And that would be a horizontal translation of the graph to the right 2 units. Our parameter tells us our transformation. Our h is a positive 2. That means we go to the right 2 units. We're adding 2. And our k is negative 4. That's a vertical translation of the graph down 4 units. All right, so now we're going to keep going, and what we're going to do now is we're actually going to go ahead and transform these points. So they gave us our transformation rule already, the x plus 2, comma, negative 3, y minus 4. So what we need to do is we need to take each of these reference points, or these points on the graph, put them into our transformation rule, right? This will be our x and our y, each one. You plug our x's and our y's into our transformation rule, and that's going to give us our new points, our new transform points. So our transformation rule is x plus 2. So x plus 2, in this case, our x is negative 1. We're adding 2 to it. And then for our y, we said it's negative 3y minus 4. That's what we said there. We underline each one in the correct color so we know which one's going from where. So our blue is negative 3y minus 4. So they already gave us our y value of 1. So we just put in the negative 3 and the minus 4, and we figure it out. All right. So Our x is negative 1 plus 2, so that's just going to be a 1. And our y is going to be a negative 3 times 1, or negative 3 minus 4, which will be negative 7. For 0, 0, we have 0 plus 2, and then negative 3 minus 4. Right, they gave us, we already put in our x and y to the equation. We just put parameters into it. So when we do, we end up getting 2, comma, negative 7. Oh, sorry, negative 4, not negative 7. Got confused with the point above it. So 2, negative 4. There we go. And then for the last one of 1, 1, same thing. We add 2 to x. And then for the y, it's negative 4, or sorry, negative 3 minus 4. Sorry about that. Negative 3 minus 4. We're going to solve this out. Our x value in green will be 3. And our y value, negative 3 times 1 is negative 3, minus 4 is negative 7. So what we're going to do here in the graph is we're told we need to graph it as well. So I'm going to graph f of x. And when we do, this is going to be our points right here. We have 0, 0, negative 1, 1, and 1, 1. So our function will look something like that. Right here in red, we'll put f of x, so we know what it is. And then our g of x, I'm going to do that in blue. That's going to be our transform points we figured out here. So we have 1, negative 7, 2, negative 4, and 3, negative 7. All right? I'm terrible at drawing graphs, but it's going to look something like that. All right? And that's going to be our g of x. So a couple things we can kind of see right away is that we have the transformation. We're just going to list our a, b, h, and k. Negative 3. Our h is 2. And our k is negative 4. So our h tells us our translation is left to right. And our h is 2. And we can see that we actually went to the right by 2. We went to a 2, negative 4. So from our parent function to our transform point, we went to the right by 2. Right? And at the same time, we went down 4. And that's where our k was, negative 4. We had a vertical translation, down 4. And at the same time, for our b is just 1, it doesn't do anything. But our a value of negative 3, we did reflect vertically, we did reflect over the x-axis. So that's where that's where the negative comes from. And at the same time, if you compare the blue graph to the red one, the blue one looks a lot narrower, right? Because if we took it and we stretched it out. And that's exactly what a vertical stretch does. It stretches out the function. So we did do our transformations, right? Our a equals negative 3. We did reflect it vertically over the x-axis, and at the same time, that 3 makes it stretch out, and we did stretch it out. All right. So here you should have this already. If you don't, you can copy them down in your notes again. It is very important. Same thing with this transformation rule here. Incredibly important. I talked about it in the previous video because I wanted to show you guys the transformation rule before we talk about it today. And this is it. You should know it. You should have it written down. You need to know how to memorize. We use both these equations and rules pretty much all year. So the sooner you get comfortable with them, the sooner you know it, the sooner you get better at it, the easier this course will be for you. All right. So going on in your notes, we have this equation right here, this g of x. And what we need to do is we need to give this transformation equation, a transformation rule. All right, so before we ever actually figure out our transformation rule, I always say list out your a, b, h, and k. When you do that, you have everything organized. You know exactly where to plug what into the transformation rule. So figure out our a. Our a here is negative 2. Our b, remember b's are a little weird. You have to flip them. So 1/3 becomes 3. That's our b value. Our h, that'll be the term right here, a positive 4. Right? It's x minus 4, so our h will be it'll be just plus 4. In our k on the outside, it's going to be 5. Remember, everything inside the parentheses is always going to act different and more weird than you'd expect. So always keep that in mind to figure out your b and your h. All right? So that's what our a, b, h, and k is. And what we need to do now is we need to list out our transformation rule. So remember, it's bx plus h, comma, ay plus k. My suggestion is always write this out. Anytime you take a quiz or test, have it memorized, just brain dump it right on the paper, write it down right away so you don't confuse yourself later on. Bx plus h, ay plus k, and we're just going to plug everything in. Our b is 3. We don't have an x, plus our h of 4. Our a is -2. We don't have a y, plus our k of 5. That's our transformation rule. All right, so let's keep going. Here, actually, I want you guys to try this one out yourself. We did an example just like it, and they give us the transformation rule anyway, so it shouldn't be too bad. List out the A, B, H, and K, and tell me what it does, if it's a vertical stretch or compression or whatever it is, horizontally too, whatever, stretch, compression, whatever. Tell me what all this stuff is. Try to fill it out yourself, and they already kind of listed this out, and at the end, I want you guys to graph both functions as well, or actually just graph g of x, sorry. Do that, see what you get, and compare with what I'm about to post on the screen in a few seconds, all right? All right, so this is what you should have gotten. Your A is 1, we don't have an A. Our B is 2, that's a horizontal stretch by a factor of 2, no reflection. Our H is -5, so we go to the left by 5 horizontally. Our K is 2, so we go up 2 vertically. These are what your points should have been: -7.3, -5.2, -3.3. They listed it out for us. You just need to do the algebra for it. And when you graph those new points, that's what your graph should look like. And something I want to point out before we go on to the next slide that is pretty important. It's going to be, sorry, I did not mean to erase that, -5.2. It's going to be this vertex point, all right? So with the vertex point, our x and our y are 0, right? So when we plug the x and y of 0 into our transformation rule, so our transformation rule is bx plus h, comma, ay plus k. We plug in an x of 0 and a y of 0 to these equations. We get b times 0 plus h, comma, a times 0 plus k. B times 0 is just going to be 0. A plus 0 is just going to be 0. And we're left with h and k. So what this means is that our vertex of 0, 0 is going to give us the point hk. And we can see here, our h down here is -5. They gave us -5, and our k is 2. They gave us a term of 2. That should be 3, kind of erase it. So when it comes to quadratics or x squared functions, your vertex will always be transformed to the point hk. And if you go back to the previous problem we did over here, same thing. Our h was 2, our k is -4, and that's what we got here, 2, -4. Your vertex will always be the hk point, all right? That is really important to know, so that's why I'm pointing it out. So do know that, do understand that your vertex of 0, 0 will give you hk. All right, so we're going to keep going. Number 10 is the function f of x equals x squared, an even function, an odd function, or neither. Fx equals x squared is going to be even. And that's because really two things you can think about. And that's because, you know, the definition is f negative x equals fx. The other way is because if you have a function f of x equals x squared, that has a line of symmetry over the y-axis, sorry, at x equals 0. When that happens, it's an even function. If a function has a line of symmetry over the y-axis, that makes it an even function, as well as holding for this equation right here, and both hold true. So f of x equals x squared is an even function. For number 11, the graph of the parent quadratic function f of x equals x squared has a vertical line x equals 0 as its axis of symmetry. All right. Identify the axis of symmetry for each of the graphs of g of x in parts A and B. Which transformations affect the location of symmetry? So we're going to go back and look at both these graphs. So we'll look at B first, since that's what pops up first. And we can see that our line of symmetry will be this line right here. It's the line that goes through the vertex. I think I said it in passing in the beginning of this video, but the vertex is going to be the center of the graph. That's the middle of the graph. It really is just the center of it. I don't know what else to say about it, but it is the center of the graph. So that makes where the line of symmetry is going to be. The line of symmetry will be the line that goes right through the vertex. So in this case, it's x equals -5. And if you go to the other one, right here in blue, same thing. We're going to draw our line of symmetry. It's going to be right through the vertex, which is at x equals -2. Or in other words, x equals h. And that's because the h term will always be the x of the vertex. All right? And same thing here in this one right here on B. That line happens at x equals h, because our h is -5. Our h is going to be the x value of the vertex. So in this case, it's always going to be x equals h. And that's because the h term is always going to be the x value of your vertex. And the x value of the vertex is where your axis of symmetry will be, because the axis of symmetry has to go through the vertex. And it's x equals that x value of the vertex. So x equals h. And which transformations affect the location of the axis of symmetry? Well, if x equals h, the only transformations that will affect it will be your h term. You change your h, you change your axis of symmetry, or your line of symmetry, whatever you want to call it. All right, so here, describe how to transform the graph of f of x equals x squared to obtain the graph of the related function. I do want you guys to pause the video and try this out yourself as well. We don't give you the transformation rule here. Honestly, I don't even know what that part right there even means, so don't worry about it. But what I do want you guys to do, list out your A, B, H, and K terms, list out your parameters, and then give me the transformation rule. All right, so T rule, the transformation rule, figure it out, and then write it out. Pause the video, try it yourself. It is very good practice to get this stuff in. So pause the video, try it out. In a quick second, I'll post the answers to all this. And also, don't forget the graph. All right, this is what you should have gotten. So -1, 1, or sorry, before we even get to that, your A, B, H, and K should have been 1, -1, 4, 3, and 1 respectively. Your transformation rule would have been -1/4 times x plus 3, comma y plus 1. That's the setup. Once you have that, we have our original points right here. You're going to take these, put them into the transformation rule, and when you do, you get these points right there. All right? And that's what you should have gotten. That's what your graph should have looked like. If you got something different, make sure your transformation rule is the same as mine. Make sure your A, B, H, and K are the same as mine. If your transformation rule and your A, B, H, and K are the same as mine, go and double check your algebra. This problem was weird. The numbers were a little weird. So you might have to go double check your algebra, make sure you didn't add or subtract something incorrectly. All right, we're going to keep going. So here we're talking about modeling with a quadratic function, and all this is all really saying is just that, well, really what we're going to do is we're just going to be transforming functions or figuring out the function of an equation from a problem, from a word problem, from a picture. That's really what we're doing. And on top of that, we're really only going to be dealing with A. Because we've said it, B's are really weird. We're only dealing with A, H, and K. We're not dealing with B. We're only going to deal with A and sometimes maybe B. You deal with one or the other, never both, but most times it will only deal with A. All right, so on to an example. So we're told the old stone bridge over a river uses a parabolic arch for support. In the illustration shown, the unit of measurements for both axes is feet, and the vertex of the arch is point C. We need to find a quadratic function that models the arch and state the function's domain. So we're going to analyze this picture first, the picture and the problem. The first thing we're told is the shape of the arc is parabolic. That's the first thing we're told. Next, we're told the vertex of the parabola is at point C, as told to us in the problem, and that's at 27, -5. And then lastly, two other points in the parabola. That'd be our A point and our B. So 2, -20, and 52, -20. All right. So what we're going to do is we're going to, what this thing says right here in the pink box, we're going to plug the vertex H of K and one other point X, Y into this function right here, and we're going to solve for a. All right. So we'll go through this step by step. First thing we need to do is figure out our h and k. Right. Remember, our h and k is our vertex. I showed that to you earlier in the video. Our vertex is hk, which makes our h 27 and our k -5. All right. So we know our h and k, so we'll plug that into our equation first. Y equals a times x minus our h of 27, all squared, plus our k of -5, plus -5 will just be -5. All right, so we see here that we're still left with 3 variables. And to solve this equation out, we need to have only one. So what we're going to do is we're going to plug in an x and y point. All right, an x and y point can be any point that's on the graph. All right, and the two ones we're given are 2 -20 and 52 -20. So we can use either one of those to plug into our equation to figure out our a value. All right, it doesn't matter which one you choose. I'm going to go with 2 -20 just because the numbers are a little smaller and they'll be a little nicer for me. So 2 minus 27 squared minus 5. So we plugged in our x and our y into our equation, and now what we need to do is we're going to solve this out for y. All right, so add 5, -15 equals a. 2 minus 27 is 25, all squared. 25 squared is 625. So I'm doing this kind of quickly, but just algebra. Take this step by step. Use a calculator if you have to, a 4-function one, and take this step by step. Don't forget the a. You need to isolate the a. So divide by 625 on both sides. So we get that a equals -15 all over 625. Don't ever leave it like this. If you can reduce the function, reduce it. So this reduces down. You can divide by 5 on both sides to get -3, 125. So that's what our a value is going to be. All right. So we take this, we take our a value and plug it back into the equation that we started with. This one right here. We get that y equals our a of -3 all over 125 times x minus h of 27 all squared minus 5, which is our k value. All right. Do not keep your x and y into the equation. We do not want that. The y and x are just placeholders for any y or x that happens in the problem. So we don't want that. We just want our a, h, and k terms or our parameters in the equation. So leave it y equals a times x minus h minus 5, whatever it is. Just do not plug in your x and y back into the equation. All right. So that's the equation. And what we need to do now is we need to restrict our domain, right? That's what it says down here. We need to restrict it. And that's because if we go back to the problem, we have this bridge, but we're saying this bridge only goes from point A to point B. It doesn't go any further than either of those points. So we need to make sure when we're giving the equation, we're saying this equation only applies from the beginning of the bridge to the end of it. Anything after it, we don't know what's happening. We don't care. We only care for the bridge. And we only care for the x coordinates of the bridge, which will be from, let me double check. You get an x value A to the x value B, so from 2 to 52. What form you put it in, we didn't ask to use a specific one. Use whatever form you want, but we go from 2 to 52. All right? And there's one more problem in the next slide. I want you guys to pause it again, try it out yourself, and I'll give you the answer in a second. All right? So this is what you should have gotten. Our vertex is at C point 3, so our vertex is HK. So our vertex is, our H is 3, our K is 3. When you plug that into the equation, you get y equals a times x minus 3 squared plus 3. Then you plug in a pair of x and y points. It has to be a pair. You cannot pick one x from one and the y from the other one. You have to take both the x and the y from one equation. So I use -2, 4. I just thought it would be a little easier. It doesn't matter which one you use. You should get the same equation either way. You plug that in, and you end up getting a to be 1 over 25. Plug that back into the equation without the y and x. So y equals 1 over 25 times x minus 3 squared plus 3. And you get the restricted domain because we only care about the parabola on the problem. The problem goes from point A to point B only, or from an x value of -2 to an x value of 8. And that's how we restrict our domain. That's how you figure out this problem. And I think that's the end of the notes. Yep. I'll get to elaborate. I didn't see this here. So I guess we'll go ahead and look at this too. So elaborate, what is the general procedure to follow when graphing a function of the form g of x equals a times f of x minus h plus k when given the graph of f of x? So we talked about this. That's going to be everything in this pink box right here. All right. So plug the vertex hk and one other point xy into the equation of y equals a times x minus h squared plus k, and then find a. That's how you do it. So here I'm just going to write pink box. It's in your notes as well. The pink box is how we do it. All right, 15. Sorry, I had to pause it really quickly to reread it a few times because I'm pretty sure it's basically saying the same thing as 14. It's really just going to be everything in the pink box. Your H and your K come from your vertex, and your A you get by solving with a reference point. So that's how you determine the values A, H, and K. You just you just HK comes from the vertex, A, you solve it out. Pretty much everything we talked about that's said in that pink box is what answers 14 and 15. And then 16, essential question check-in. How can a graph f of x be transformed? And that's just your A, B, H, and K points. Right, A, B, H, and K. My B looks like an H. Yeah, A, B, H, and K. Or in other words, it can be stretched horizontally and vertically. It can be compressed horizontally or vertically. It can be moved up, down, left, or right, and it can be reflected vertically or across the y-axis or x-axis, or reflected horizontally or across the y-axis. So that's how it can be transformed. That now should be the video. I think that's the end of it. It is. All we have left is the homework. So anyway, guys, try and keep these videos less than 30 minutes now. Hopefully this helped. And if you're watching this over the weekend before the quiz on 1.3, don't forget about it. And hopefully this helped.